Have you ever looked at a clock and wished you could turn back time? What if I told you that, in a way, you already are a time traveler? Think about it. Hey everyone, and welcome to a brand new episode from AskDrift. Today, we're diving headfirst into one of science's most mind-bending questions. Is time travel possible? Let's get one thing straight. You, me, everyone on this planet, we are all time travelers. We are constantly moving forward into the future at a steady rate of 1 second per second. Pretty straightforward, right? But what about traveling faster into the future? Or even going back? This isn't just science fiction. The idea is rooted in one of the most brilliant minds in history, Albert Einstein. His theories of relativity completely changed how we understand space and time. Before Einstein, we thought of time as a universal constant. A clock in New York would tick at the exact same rate as a clock on Mars. But Einstein showed us that time is not absolute. It's relative. Imagine time as a river. For most of us, we're just floating along with the current. But what if you could build a faster boat? Or even find a way to paddle upstream? This is where things get really interesting. Let's start with traveling to the future. According to Einstein's theory of special relativity, the faster you move through space, the slower you move through time. This is a phenomenon known as time dilation. It sounds like something out of a movie, but it's real and has been proven. GPS satellites in orbit around Earth have to account for this. Their clocks run slightly faster than clocks on the ground because they are moving at incredible speeds. If we didn't adjust for time dilation, your GPS would be off by several miles every single day. So, in a tiny way, astronauts are already time travelers. They return to Earth having aged just a fraction of a second less than the rest of us. But what if we took this to the extreme? Imagine a spaceship that could travel at 99.9% the speed of light. If you took a 5-year round trip on this ship, you would return to Earth to find that decades, maybe even centuries, have passed. All your friends and family would be gone. The world you knew would be a distant memory. You would have successfully traveled into the future. The technology for this is far beyond our current capabilities. But the physics says it is absolutely possible. Another way to travel to the future involves gravity. Einstein's theory of general relativity tells us that massive objects warp the fabric of space-time. Think of it like placing a heavy bowling ball on a trampoline. It creates a dip. Time moves slower in stronger gravitational fields. So, someone living at sea level ages slightly slower than someone living on a mountain. The difference is minuscule, but it's there. To see a more dramatic effect, you'd need a much stronger gravitational field, like the one around a black hole. A black hole's gravity is so intense that not even light can escape. If you could orbit a supermassive black hole without getting sucked in, time would slow down dramatically for you. An hour spent near the black hole could equal years or even decades back on Earth. So, traveling to the future, it seems the universe has left a couple of doors open for us, at least in theory. But what about the one everyone really wants to know about? Traveling to the past. This is where things get much trickier. The laws of physics as we understand them seem to have a strong preference for moving forward. This is often called the arrow of time. Think about it. You can break an egg, but you can't unbreak it. You can stir milk into your coffee, but you can't unsteer it. The universe tends to move from a state of order to disorder, a concept known as entropy. Going back in time would mean reversing this fundamental process. If you're finding this journey through space-time as fascinating as I am, do me a quick favor and hit that like button. It really helps the channel. And if you subscribe, you won't miss our next deep dive into the universe's biggest mysteries. Alright. Back to the past. While most physicists are skeptical, some theoretical possibilities exist. One of the most famous is the concept of a wormhole, also known as an Einstein-Rosen bridge. A wormhole is a theoretical shortcut through spacetime. Imagine our universe is a giant sheet of paper. To get from one side to the other, you have to travel across the whole surface. But what if you could fold the paper and poke a hole through it? That hole would be a wormhole, connecting to distant points in space and, potentially, to different points in time. You could step through one end and emerge in the same location, but 100 years in the past. The problem, wormholes are incredibly unstable. Scientists believe they would collapse in on themselves the instant they form. To keep one open, you would need something called exotic matter, a hypothetical substance with negative mass and negative energy. We've never observed exotic matter. We don't even know if it can exist. So, while wormholes are a fascinating mathematical possibility, they remain firmly in the realm of theory for now. Another mind-bending idea is the Tipler cylinder. This is a hypothetical, infinitely long, and incredibly dense cylinder spinning at nearly the speed of light. According to physicist Frank Tipler, its rotation would drag space-time along with it. This frame-dragging effect could create a path that allows a spaceship to travel back in time. By flying a specific spiral route around the cylinder, you could arrive back at your starting point before you even left. But again, the practicalities are staggering. You'd need a cylinder of infinite length and unimaginable density. It's a fun thought experiment, but not a practical blueprint for a time machine. And even if we could build a time machine, we'd have to deal with the paradoxes. The most famous is the grandfather paradox. What happens if you go back in time and prevent your grandparents from meeting? If they never meet, your parent is never born. If your parent is never born, you are never born. But if you were never born, how could you have gone back in time to stop them in the first place? It creates a logical loop that seemingly has no solution. Some physicists propose solutions. One is the self-consistency principle, which suggests that you simply can't change the past. The laws of physics would conspire to prevent you from creating a paradox. Maybe you'd try to stop your grandparents from meeting, but your car would break down. You'd get lost, or you'd accidentally introduce them to each other yourself. The outcome would remain the same. You would just become part of the history that already happened. Another possibility is the many worlds interpretation of quantum mechanics. This theory suggests that every time a decision is made, the universe splits into multiple parallel universes, one for each possible outcome. In this scenario, if you went back in time and changed something, you wouldn't be altering your own past. You would simply be creating a new alternate timeline, a new branch of reality. Your original universe would remain unchanged. You could prevent your grandparents from meeting in this new timeline, but it wouldn't erase you from existence because you belong to the original timeline. You would just be a visitor in a different reality that you created. So let's wrap this all up. Is time travel possible? The answer is a definite maybe. Traveling to the future seems physically possible, though technologically out of reach for now. Just get on a really fast spaceship or hang out near a black hole. Traveling to the past is a much tougher nut to crack. It's filled with theoretical hurdles like the need for exotic matter and the thorny problem of paradoxes. While ideas like wormholes and multiple universes offer potential loopholes, they remain unproven. But the quest to understand time is about more than just building a DeLorean. It pushes the boundaries of our knowledge, forcing us to question the very nature of reality, causality, and our place in the cosmos. Here's a final thought to leave you with. The light from the Andromeda Galaxy, our closest galactic neighbor, takes about 2.5 million years to reach us. So when you look at it in the night sky, you are literally looking 2.5 million years into the past. Time travel, in a way, is already here. Thank you so much for joining me on this incredible journey through space and time. What do you think? Is time travel to the past possible? Let me know your theories in the comments below. Don't forget to like, subscribe, and hit that notification bell so you can join us on our next adventure. See you next time.